In a single stage RC coupled amplifier stage, what are the phase shifts introduced at lower frequency and upper 3 dB frequency respectively? RC coupled amplifier at low frequency acts as a high pass filter, so it will phase lead by 45 degrees, and at high frequency it will act as a low pass filter, so phase frequency lags 45 degrees, so angle will be 315 degrees. In the given option 315 degrees is not given, so nearest option is 225 degrees. The effect of cascading the amplifier stages. By cascading the amplifier stages, gain will increase, voltage gain will increase, and bandwidth will reduce. By increasing the voltage gain and reducing the bandwidth, we will get gain into bandwidth as constant. By cascading the different amplifier stages, the individual voltage gains are added. In a typical RC coupled amplifier, the gain falls at high frequency due to internal capacitance. The amplifier has to use coupling capacitors in the input side and output side for isolating or removing DC biasing circuit and AC signal. So for removing the AC signal, amplifier must use coupling capacitors. So to delete the DC biasing circuit and AC signal, amplifiers use coupling capacitors at both input side and output side. For most of the FET configurations and for common gate configurations, the input impedances are: for FET configurations, input impedance is high, and for common gate configurations, input impedance is low. See, now consider FET configuration. FET configuration is nothing but which consists of common source and common drain. Input at gate current will be 0, so input impedance will be high. For common gate, input will be at source and source current is 0, is not equals to 0, so input impedance is low. So finally for FET configuration, input impedance is high, and for common gate configurations, input impedance is low. In negative feedback amplifier with open loop gain minus A0 by 1 plus j omega by omega naught, where A0 is greater than 0 and beta feedback factor is also greater than 0, will have 3 decibel cutoff frequency at. Directly remember, omega at 3 decibel frequency is omega naught into 1 plus a naught beta. It is multiplied with omega naught, so overall omega increases. So a 3 decibel cutoff frequency, omega is equals to omega naught into 1 plus a beta. For transconductance amplifier, the input and output resistance are: input acts as a voltage source, so it has high resistance, and output is also high. So remember, there are 4 types of amplifiers: trans resistance amplifier, first one; second one current amplifier; third one voltage amplifier; fourth one transconductance of amplifier. You know, in digital circuits we will give 4 types of inputs: 0 0, 0 1, 1 0, 1 1. 0 represents low and 1 represents high. So now go trans resistance 0 0, so it has low input resistance, low output resistance. Second one, current amplifier 0 1, it has low input resistance and high output resistance. Third one, voltage amplifier, it has high input resistance and low output resistance. And fourth one, transconductance, it has high input resistance and high output resistance. First one, trans resistance amplifier, which have low input resistance and low output resistance. You can write this trans resistance amplifier as voltage shunt feedback. There are two terms we use for finding the input and to find which type of feedback it is. We use mixing and sampling. First one is you go with trans resistance shunt. Second one current amplifier shunt series. Third one voltage amplifier series shunt. Fourth one transconductance series. First one trans resistance shunt. This represent first one shunt is mixing, second one shunt is sampling. Now other side you will write sampling mixing. In shunt, sampling means voltage and mixing means shunt, so voltage shunt feedback. Next shunt series, here shunt is mixing and series is sampling. So other side you will write for series sampling it is current and next mixing is shunt feedback, so it acts as current amplifier. Third one voltage amplifier, it is series shunt, so mixing is series and sampling is shunt. Other side you will write for sampling shunt you will write voltage series feedback. And fourth one transconductance series, so mixing is series, sampling is series, so you will write current series feedback. It is transconductance amplifier. An astable multivibrator is also called as free running oscillator. An astable multivibrator circuit forces an operational amplifier to operate in saturation region. So both statements are right, true, and 2 is not correct explanation of A. This is the right answer. The power amplifiers in which the operating point is so adjusted that collector current flows only during positive half cycle of input signal, that is class B amplifiers, and class A amplifiers it flows for complete cycle. Class AB more than half cycle. Class C it will flow for less than half cycle. Now consider the following statements. When Darlington circuit and normal single stage emitter followers are compared, both have voltage gain as unity and emitter follower has low input resistance. So current gains will be different. The Darlington pair has higher input resistance and lower output resistance. For a silicon NPN transistor, the base to emitter voltage is 0.7 and the collector to base voltage is 0.2. Then transistor is operating in which mode? As collector to base voltage is 0.2, collector acts as N terminal and base acts as P terminal. So it is a reverse biased condition. So it acts in normal active mode. Early effect is a modulation of effective bandwidth by collector voltage. Early effect makes the base width narrow. Base width narrow means bandwidth decreases. Bandwidth decreases when collector to base voltage increases, bandwidth decreases. In BJT, ICO and is equals to ICBO is equals to 2 microamperes and alpha is given as 0.99. He is asking about the value of ICEO. ICEO is equals to 1 plus beta ICBO. Beta and B comes in the right hand side. You will get the answer as 200 microampere. In a phase shift oscillator using an FET at a certain frequency, the phase shift introduced by RC network is 180 degrees. Then the total phase shift from the gate around the circuit and back to gate will be 0 degrees. In a complete loop, in a closed loop system, A beta is equals to 1 at an angle of 0 degrees. Angle will be 0 degrees. Which one of the following is the correct in the feedback circuit having 3 resistance and capacitance elements with the condition R2 is equals to R3 is equals to R bar, C1 is equals to C2 is equals to C3 is equals to C bar for phase shift oscillator. The frequency of your RC phase shift oscillator is equals to 1 by 2 pi RC root 6, that is equals to 0.065 by RC. Shunt type regulator is suitable for which of the following? A. Low current high voltage, B. Low current low voltage, C. High current low voltage, and D. High current high voltage. The answer is C. High current low voltage. Sinusoidal signal of 100 Hz is applied to the amplifier. The output current is I naught is equals to 20 sin 628 plus 2 sin 1250 plus 1 sin 2512t. So here omega is equals to 2 pi into 100. You will get 628. So I naught consists of 628 terms. So it is the fundamental frequency. If you multiply that 628 term into 2, you will get 1256. That is the second harmonic component. And if you multiply this 628 term into 3, or 4, 628 term into 4, you will get 2512. Now he is asking the approximate power rise. Due to crossover distortion, you know power is equals to IRMS square. To find the IRMS square, you will get fundamental current RMS square is equals to 200 by 2. So total RMS square, you will get 1 by 2 into 20 square plus 2 square plus 1 square. You will get 405 by 2. So there is a percentage of increase. So percentage of increase is difference between the total current minus fundamental current divided by fundamental current into 100. You will get the percentage increase in the power, that is 1.25. In this question he is asking what is the main source of distortion in push-pull amplifier. A. Fundamental component, B. Second harmonic component, C. Third harmonic component, D. All even harmonics. See, in push-pull amplifier, all even harmonics are present and there is only problem due to the crossover distortion, and the distortion is known as push-pull distortion, and it is present in the class B push-pull amplifier. And the main source of distortion is third harmonic content is the main source of crossover distortion. Low pass RC circuit, the input waveform is as shown in the figure below. What will be the output waveform if the time constant of the circuit is equals to the time period of the input signal? Option C is the right answer, which will get the triangular waveform. The efficiency of a class B amplifier is 72% when the supply voltage is 24 volts. He is asking peak to peak output voltage. You know, peak to peak output voltage is nothing but the peak voltage by 2. But here efficiency, you can write the formula as pi by 4 into V peak by Vm. Efficiency is given as 0.72 and pi by 4 written is as it is, and V peak we have to find out, and Vm is 24 volts. So you will get 22 volts is the right answer. Here peak to peak output voltage is 22 volts. For class A operation of a common emitter transistor amplifier, the operating point cannot be fixed near VCE is equals to 0 point. Actually, class A operation should be done in active region. When VCE is equals to 0, that implies that is the saturation point. So for class A operation of a common emitter transistor amplifier, the operating point must be in active region. So it cannot be fixed near the saturation point. During the positive half cycle of the input cycle, the transistor may be driven from active region to transistor region, active region to saturation region, thus losing the class A wave shape in the output. Class A wave is full cycle and it loses its wave shape when it moves from active region to the saturation region. So both A and R are true, and R is the correct explanation of A. Active load is primarily used in the collector of a differential amplifier of an op-amp, which is used to increase overall differential gain. In this question, Consider the following statements regarding the differential amplifier. The differential amplifier get an differential output offset voltage. This is due to the mismatch between the FET parameters, and we use different resistors even though they are marked nominally equal. Difference between the value of resistors values, that's why the offset voltage is formed, and variation in the output voltage of the circuit. The output voltage must be constant. If there is any variation in the output voltage of a differential amplifier, you will get a differential output offset voltage. A two-stage amplifier with negative feedback A can become unstable for larger values of beta, becomes unstable at high and very low frequencies if A is very large, becomes unstable when pole frequencies become complex. Actually, by using the negative feedback, the system is always stable. We see this type of questions in the control systems also. By using the negative feedback, sensitivity decreases and stability increases and reliability increases. In the same case, in the two-stage amplifier, by using the negative feedback, stability increases and it becomes always stable. Identical amplifiers, each having a voltage gain of 50 and cascaded. The open loop voltage gain of a combined amplifier is, open loop gain is equals to 50 cube. When you convert it into decibels, 20 log 50 cube, you can write it as 60 log 50. Approximately you will get it as 1 or 2 dB. To balance the offset voltage of an op amp, a small DC voltage is applied to the input terminals where connection is in series with non-inverting input. Non-inverting input means series with the positive terminal. Same as in DC motors, as a residual flux, a small DC voltage is applied to the input terminals in order to balance the offset voltage. So we will connect a small DC voltage in series with non-inverting input, that is positive terminal. Which one of the following statements is correct for active filter using op amps? High frequency response is limited by gain bandwidth product and slew rate of the op amp. That is the right option.